standing waves in a thin string, Melde's experiment. This experiment is to determine the frequency of an electrically vibrating metal tip by forming standing waves on a thin string. So the materials and equipment required are Melde string setup, which consists of a vibrator, a vibrating tip. Next is the string, then clamp, pulley, then weight hanger with slotted weights. So this is a close-up view of the Melde string setup with the vibrator, vibrating tip and the string marked. Melde string experiment is a very easy method for determining the resonant vibrations of a stretched string or wire and investigating the laws which govern such vibrations. It consists of a string of 1 or 1.5 meter long, which is fixed at one end to an electrically vibrating tip. The other end of the string passes over an adjustable pulley and is fastened to a weight hanger. The vibrations of the metal tip is at right angles to the length of the string. In the transverse mode of vibration, the tip of vibrating metal tip is in a direction at right angles to the length of the string. The time during which the tuning fork executes one vibration, the string also completes one vibration. In this case, the thread of length L vibrates with one loop, that is 2 nodes and 1 antinode. So if we see, we have one loop formed like this with 2 nodes and 1 antinode. So if we see on the string, we have 2 nodes and an antinode. Now we will see about the procedure to determine the wavelength of the standing wave on a tension string. So the first step is to attach one end of the string to the tip of the vibrating fork in the Melde string apparatus and place the free end of the string over a pulley. All this has been done previously itself. So now we are going to attach the weight hanger to the free end of the string passing over the pulley. The mass of the weight hanger is 50 grams. Now we excite the tip of the vibrator by switching on the power supply in the apparatus. Then adjust the length of the string between the tip of the vibrating metal tip and the pulley suitably so that standing wave pattern with one loop is formed. Note down the length between the tip of the vibrator and the pulley end. So if we see, for the mass of 50 grams, the length in between the vibrating tip and the pulley is observed to be 30.5 centimeters. Now we have added the second weight to the weight hanger, so the load is 100 grams. Now we are going to measure the distance at which we are able to get 2 nodes and antinodes in between the vibrating tip and the pulley. So the distance is seen to be 42.5 centimeters. Now we are going to add one more weight and adjust the distance again in order to achieve one loop in between the vibrating tip and the pulley. Now we are going to measure the distance. The distance is noted to be 49.5 centimeters. One more weight is added. and the distance is adjusted and measured. For a load of 200 grams, the distance is seen to be 55.5 centimeters. We are going to increase the load to 250 grams now and measure the distance. After forming a single loop in between the vibrating tip and the pulley, the distance measured is 66 centimeters. Another weight is added. Now the load is 300 grams. Again the distance is adjusted to form a single loop and measured. The distance is observed to be 71.5 centimeters. So the load is increased till 350. So we are going to add a final weight. Now the load is 350 grams. We are now adjusting the distance such that we form a single loop and measure the distance. So the distance is observed to be 79.5 centimeters. So the same procedure is followed during unloading also. We are going to remove one weight after the other and measure the distance at which we are able to form a single loop.
This is the tabular column for entering the length between the vibrating tip and the pulley after forming a single loop and noting the readings while loading as well as unloading and then using them to calculate the frequency of the vibrator. So if we see for the load of 50 grams, the length is observed to be 30.5 centimeters. For a mass of 100 grams, the length is seen to be 42.5 centimeters. For a mass of 150 grams, the length is observed to be 49.5 centimeters. For a mass of 200 grams, the length is observed to be 55.5 centimeters. For 250 grams, the length is observed to be 66 centimeters. For the load of 300 grams, the length is observed to be 71.5 centimeters. And for the load of 350 grams, the length is seen to be 79.5 centimeters. So we are going to repeat the procedure of measuring the length between the vibrating tip and the pulley by forming one full loop in between the vibrating tip and the pulley while unloading also. So as 350 is going to remain the same, we are putting down the same reading of 79.5 centimeters in the unloading column of 350 grams. Now we have removed one weight and we have the load to be 300 grams and the reading or the length that is observed is 72.5 centimeters. So likewise we have reduced one weight after the other and noted down the length between the vibrating tip and the pulley and the readings are shown here. The next step is to calculate mean L, which is done by adding the reading corresponding to loading and unloading and then dividing them by 2. So the obtained mean L values are given in this tabular column. The next step is the calculation of m by L squared. So we have calculated the m by L squared values for all the loads starting from 50 to 350 and shown it here. So now the final step is the calculation of the frequency of the fork using this formula given here. So the obtained frequencies are given in the last column of the tabular column here. So the last step is to determine the mean frequency, which is got by adding the values that are there in the calculated frequency column and dividing it by the number of values. So if we see here, we are going to add the values obtained for 50 grams to 350 grams and then divide them by 7. So the mean frequency is seen to be 50.36 Hertz. Finally, the measured frequency of the electrically vibrating metal tip is observed to be 50.36 Hertz.